Right, thank you. Thank you. So good afternoon, everyone. Today we're going to talk about zero knowledge, and we are pretty excited that we have a lot of co-founders here right now with us. Can you guys give us like a quick intro, what you've been working on, and what about zero knowledge proof, or anything about zero knowledge that you're working on?
Hi, I'm Sandy. I'm one of the co-founders for Scroll. Been working on a ZK scaling solution. We've been live for almost a year now, and we've just hit the #1 TVL metric for ZK rollups in general. So very excited to be here, and we'll share a lot more about what ZK is in the latest development later. So I'll leave that for the rest of the panel.
Hello everyone, I'm Victor. I'm the co-founder of Brevis. So Brevis is building a ZK coprocessor, which essentially allows the DApps to have the off-chain verifiable computing capability. For example, to leverage historical on-chain data to build DeFi-driven data, and all this kind of new exciting stuff. I'm happy to be here. I know it's lunchtime, so thank you for all being here.
Hello, my name is Neil Fan. I'm a co-founder of Scalable. So Scalable is a hardware accelerating ZKP startup, and we recently launched our testnet for doing a ZK proof layer. So it's a layer for both ZK proof generation and also verification. Yeah, I'm very happy to be here.
Right, thank you. So, what role do you think zero knowledge can play in the crypto space?
I think ZK is still the only solution that's trying to solve problems using math. And today we already see strong use case in scaling and privacy. But there are a few very interesting emerging use cases which are like kind of emerging but untested by the ecosystem. So things like full privacy, so like client-side proving, and there's a lot of other things that are in development. So we think of ZK kind of like a baby. You can see there's a lot of potential, but it's untested. And we're very excited, and that's why we're still investing heavily in ZK research and also ZK engineering of various products.
Right, Victor?
Yeah, I think as Sandy mentioned, I think the two primary roles they can play in the crypto space is, one is the scalability, the other is privacy. So as for the scalability, I think we have seen like applications like ZK rollup as Scroll is building, and also something like a ZK coprocessor as a Brevis Academy building is also leveraging ZK to basically let the smart contract to do computations that would be impossible without the zero knowledge proofs. And in terms of privacy, I think there's also a lot of interesting applications such as private payment, and also a lot of identity solutions, like what are things currently being building by something like WorkCoin, and also account abstraction, like ZK email is doing right now. Yeah, I think a lot of cool use cases is being building with ZK right now. Yeah.
Yeah, so I guess Victor and Sandy have done a very good job summarizing the role of ZK in the blockchain space. So I'm here just to probably add one more sentence. So as we know, zero knowledge ZKP has two nice properties: succinctness and also the zero knowledgeness. And succinctness, which can be used to scale a blockchain such as Scroll and also Brevis is doing. And the second part, the zero knowledgeness, which preserves the privacy in your computation. So you can use to do a lot of things such as ZK passport, ZK identity, ZK email. Yeah, a lot of things. Yeah.
Right, thank you. So scaling and privacy, gotcha. But right now, ZK rollups is the most widely exposed use case for zero knowledge proof. How does it enhance the user experience for the user, and what are the advantages of zero knowledge rollups over other layer 2 solutions?
In terms of dev experience, it's pretty similar to other EVM solutions, but ZK rollups does bring about some unique use cases that can only exist on ZK. So one prime example is the Canvas product that we've launched about 4 weeks ago. So within 2 weeks of launch, there have been more attestation. So it's more kind of L2 EAS attestation on Scroll than every other L2 combined historically. And that just goes to show the popularity of ZK attestation on chain as a kind of like an on-chain CV or experience proof, which users are finding interesting to play with. And also we have some interesting interlope features, like interoperability features for NFT bridge and also kind of NFT interop things where NFT builders can experience moving their valuable NFTs cross-chain in a very seamless way. So there are a few things like that. But I think fundamentally what everyone's looking forward to is a moment where the algorithmic side of ZK improvement combined with hardware acceleration gets to a kind of a sub-second interop. And that's when I think a lot more of these use cases will get unlocked.
Victor?
Yeah, I think like since Sandy is an expert in ZK rollup, so I would just add a few like high-level points. I think like as compared to other like rollup solutions like optimistic, I think one like advantage of ZK rollup is shorter withdrawing time, which enables better like user experience. The other things which has been like a heated discussion is about like the better interoperability between different like ZK rollups, such as the things like did by Polygon aggregator, which essentially allow you to have some kind of like a synchronous pattern or atomic pattern, settlement pattern between different like ZK rollups. This will be impossible like without the zero knowledge proofs. And the other things is that I heard like some people saying like eventually every rollup will become a ZK rollup. Which means like ZK is kind of like end game. So we also think like, for example, some of the optimistic rollup is also exploring the options to zero knowledgeify some of their components. For example, I think there are some like exploration about how to use ZK to do the fraud proofs for optimistic rollups. Yeah, so just to add some points. Yeah.
Yeah, I guess like Sandy is the expert to answer this question. So I'm just talking from the user's perspective. So when I'm doing like transactions on ZK rollup, I don't need to worry about like I don't need to like wait for like several days to rest assured that my transaction are finalized. So ZK has a foundation of math to secure the things, to secure your fund, to secure your transaction. So that's the best thing I think.
Right, thank you. So that does sound very promising, but today's zero-knowledge systems are pretty constrained by a lot of factors like algorithms, computational limits, etc., hardware limit as well. In what ways do you think the relevant issues can be addressed in the future?
So I think there are 3 fundamental kind of principal restraints to ZK scaling. One is algorithm. One is hardware, and one is engineering. So for algorithm, we still believe in investing in first principle thinking. We're exploring linear time proving system, which is a new thing that we'll be releasing soon. And engineering-wise, I think when we started Scroll, it was unimaginable that like quasi or pseudo real-time proving is already possible. And so we're looking at, in the very immediate future, kind of sub-second proving and also sub-second interop. So I think the call out is for the builders to start building out for that future, which is coming out very soon. And on hardware, we're collaborating very closely with a few friends of ours, Leo, for example, and on hardware speed up, and while we're optimizing our own GPU proving systems. So all in all to say, there are lots of parallel efforts to unlock the current restraints of ZK proofs, and we're very close to getting to a stage where ZK proofs is like expensive, but quite useful, to just being like the cheapest and the best by every single metric.
Victor?
Yeah, just to add one more point in terms of how the ZK would evolve, like in order to achieve better scalability. I think one important thing that we learned is that there's usually a lot of like application-driven optimization. So I think like being application-driven is also like important for like achieve a better ZK performance. So for example, like for a lot of like ZK VM applications, there's usually some applications like such as ZK core processor that requires high scalability and low latency. And there's some like specific, special like pre-compiles that like will be needed in this kind of like ZK VMs. So not only like we can have some hardware acceleration and also protocol level like progress, but also we can incorporate a lot of like application-specific logic in order to achieve better performance for those kind of like special use cases to bring those kind of use cases to mass adoption. Yeah.
Okay. Yeah. So yeah, I guess Sandy and Victor also do a very good job in answering this question. So like in my opinion, like the two bottlenecks in the ZK proof generation is like the first of all is like of course you want to make the proof generation faster, and this can be done via either like some algorithm design or algorithm improvement, or like using better hardware, such as probably like SciSig is doing it's like ZK specialized chip, and it will be probably out sometime next year. And the second part is the user friendly or probably like developer friendly. So like previously without ZK VM, like you need to write this like the ZK circuit, and you need to, and after that, after you finish your circuit, you also need to ask someone to audit your circuit to make sure it's not like under or over constraint. But with ZK VM, I guess like right now, like Score is also developing its like own ZK VM. So like you don't need to write the ZK circuit, you just need to write some Rust or Go program, and there's a compiler which will compile into the instructions for over this VM. So it's largely like simplify the development process and reduce the time significantly to like do some like ZK engineering. Yeah.
Right, thank you. So like besides zero knowledge proof, there are also new cryptographic primitives like fully homomorphic encryption (FHE) and multi-party computing (MPC). So how do you think they can be combined with zero knowledge proofs to maximize like their value towards whatever zero knowledge applications that we have nowadays?
I'm going to defer to the experts on the panel for this question, but yeah.
Yeah, I think like actually FHE and MPC is not kind of like new, or I would say newer than like ZK. Historically, actually, MPC and FHE, it's like its popularity and application has been like long before ZK become like a heated discussion right now. I think like back to maybe like 10 years ago or 20 years ago, I think MPC and FHE has already found its applications. For example, the threshold like encryption and decryption, which is one of the biggest applications of MPC. And I think like so historically, I think these two like FHE and MPC has been like more widely applied in Web 2 world, I would say. Yeah. And I think like if you compare FHE and MPC with ZK, they are both cryptographic protocols that has the capability to protect privacy, but they are different in the case where FHE and MPC is more suitable for a multi-user case, for a multi-party case, where, for example, you need to share a secret, or you need to compute over data, but you do not want to reveal your data. But ZK is more suitable for the case where you need to provide your single party or the privacy of yourself. So it's kind of like a self-proved like a technology. So I would say they cover pretty much very different use cases. So for example, in a lot of like future use cases like decentralized AI training, I think they could be combined. For example, their FHE could be used to protect the data privacy, where you would distribute those data to those kind of like decentralized training, AI training workloads. And also you would need ZK to let those kind of like worker nodes to do some sort of like a proof of work to prove that they actually did the work of decentralized training. Yeah, so that's my view about like these three like cryptographic protocols. Yeah.
Okay, yeah. So in my opinion, like ZK actually is not doing the computation. So like you are using ZK to prove a statement. So either you did this computation correct, or like you have some, like you found a like pre-image of a hash function, and so that's what we are doing. But the FHE, the MPC, they are doing the computation. So it can be coupled with like ZK to showing that you are actually doing the computation specified by your client. So like if you are using FHE to do the computation, like you preserve the privacy of their privacy of your inputs, and then you can couple it with like ZK to show that you are actually doing the computation as specified in the spec. Yeah, so normally in academia, like the ZK can be like enhance the computation of like several MPC protocols. So normally, like in MPC, you care about like you are showing the proof in the semi-honest model where like everyone just stick to the spec. But ZK can be used there to enhance, to get malicious security, which means everyone can deviate from the spec, but you can still get the privacy, or you can still get the security of your protocol as long as the participants, probably like 1/3 of them are just malicious. Yeah.
Yeah, sounds like ZKP coupled with FHE definitely gets like a lot of get the best of both worlds, where you get scalability as well as like privacy, where like you can check the validity of computations on encrypted data without actually decrypting the data. But lastly, what's your understanding and your views on the future direction of zero-knowledge proofs?
So I think we've already seen the breakneck speed of development for ZK over the last year or two, and the growth have been exponential as we expected. That is kind of according to Moore's law. And I think the arena where we're headed into is a period where the cost of ZK proving will become negligible. And also the ease of use will scale down in a reverse exponential manner. So essentially right now, ZK can only be used by rocket scientists and like superstar, like math PhDs. But going forward, I think it's going to become a lot more accessible to code and to build on. So with these combined, I think this is a very, very powerful powerful force, which is about to kind of crosswire, where the scalability plus the ease of use in combination is going to bring a lot more builder energy into the ZK space. So so I think all the previous kind of supposed cons about ZK, or the parts of ZK that is yet to mature, will start to become kind of what we call like pros only in the next few years.
Yeah, I think like on the protocol and algorithm level, I think the ZK space has like become more and more mature, and we basically, I think Vitalik just mentioned like at some point we have reached the limit of some of the proving system, and what's remaining is some of the fine-grained optimizations. For example, there's a tendency to leverage small fields, such as like the Binius, this kind of work. So I think there's on the proto level we are pretty much seeing maybe the inflection point for the ZK protocols, and also to see the actual implementation to work. I think currently, although there's a lot of like exciting research, but the actual implementation, I would say, sucks. But there's like very few like mature implementation algorithm for developers to use, basically to productionize this kind of like new protocols, so that the devs can use. I think that's definitely one of the tendencies, the trend for the next few years, to simplify dev experience, to leverage these new protocols. And the other thing I would say, there will be more and more like application-specific application of ZK. For example, the ZKML. We just like released a paper, although we haven't like public announced yet about ZK-ML to basically to leverage some of the new advances in machine learning, especially the sparsity, to combine it with zero knowledge proofs to make it to basically to tell people how to make ZK-friendly machine learning models. Yeah. So in the future, I would expect like more and more application-specific optimization for in terms of the ZK like proofs. Yeah. So that's my view. Yeah.
Yeah, so in my opinion, like I totally agree with what Sandy and Victor said. Yeah, so the scalability of the ZK proof, yeah, so that's the first point. The scalability which means like the performance of the ZK proving, like you can get it proper like in sub-second time, and also you need to build the infrastructure to get this scalability. Like people can access the ZK proving as they wish. Yeah, so like SASIC is like building infra on that part. And second is the easiness of like using ZK. So like we can achieve that using like better programming techniques and also use the help of the ZK VM. Like right now, Score is developing. Yeah, so that's my 2 cents.
Great. Thank you very much. That marks the end of this panel, and thank you once again for sharing a lot of insights. Thank you.
Thank you.
Thank you.
Thanks, Eden, and our guest for the insightful discussion. 非常感谢伊登再次呢和我们的各位嘉宾非常精彩的分享，也希望呢 ZK 这项技术呢也从科学家的手中走到更多的大型应用当中。Hope ZK can